This is video 47 in the lecture on the design of reinforced concrete beams. This lecture deals with an exercise on pre-stressed concrete. We have an isostatic beam with a span of 12 meters and a rectangular cross-section of 700 by 300 meters. It has a total bearing capacity inclusive proper weight of 20 kilonewton meter in SLS. Calculate now the needed pre-stressing force with a single radius tandem profile with a total pre-stress loss of 20% and the maximum eccentricity is 300 millimeter. Check the stress at midspan. So now we will do a design of the needed pre-stressing force. The radius of the tandem profile is L squared over 8E plus E over 2, but we will neglect the E over 2. It's 60 meters. The load balancing method, the Q is NP over R, it's 20. So that's the long-term bearing capacity of the beam was 20 kilonewtons per meter, 20. P is not known, so we know Q. Or P is 1500 kilonewton. The concrete cross-section is 300 times 700 is 210,000. W is E over V equals 24.5 million cubic millimeters. And the bending moment, because of the load, is QL squared over 8. It's 360 kilonewton meter. The top fiber. This is the stress at the top fiber. If you put in some numbers, we have minus 5.71 megapascal. And you see that the minus 5.71 megapascal is exactly the same as eta P divided by A over C. So those two terms, NPE over W and M over W, cancel each other out. So the bending moment caused by the capacity of the beam equals the P times E equals unit. So that's why we call it load balancing. You put the pre-stressing force in it in such a way that the capacity of the beam can be taken. On the bottom fiber, we do again a calculation, a check of the stress, and we find again the load balancing principle that the loads, the mobile loads, are taken by the pre-stressing force, or by the pre-stress. So now you can calculate the needed pre-stress force by the method of load balancing.